Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Seth Chaiken at University of Albany, retired Professor Seth Chaiken at University of Albany, and Seth's brother Joel. We're here to hopefully show you how to approach SAT Math questions. The emphasis is on the word approach. So, yesterday we did this question, and the answer was, 0.72. Okay, that was R. But that's yesterday, so go back to yesterday's video. So today we do this question, number 38, which is the last question on a calculator test. By this time, if you take this test live, your brain is probably completely fried. Okay, it's supposed to be the last question of the test you would take. Okay, you got the stock price of a certain company. It's worth $360. The analysis says it's going to go down 28% a week for the next 3 weeks. The analyst uses that formula to the nearest dollar, and this is a calculator question. What does the analyst believe the value of the stock will be at the end of 3 weeks? Wow, we got a little bit of a gift here at the end of the test, right? Because you just use the formula, right? Isn't that right? You just say V equals 360. The problem is you need to have R correct. Ooh, if you don't have R correct, then you're not going to get the problem right. Oh, wow. So that's the answer with the calculator. Wow.
But they want you to calculate it to the nearest dollar.
Right. So that means we really do need a calculator for this. I mean, you could do this without a calculator, but it would be unrealistic. So you got to do 0.72 up to the third power, or 0.72, 0.72. Right, 360.
That means you multiply them. You multiply 0.72 by 360 3 times.
Right, so it's 134.398. No, sorry, 369. Now you double check with your eyes. And you do the calculation again, okay? You do something like this two times because you need to double check the calculator and your pens. It's $134.369. So it seems like 0.72. Yeah, I guess so. You would think it would be lower, wouldn't you? Wouldn't you think it would be lower than that? But anyway, Seth, why don't you finish it off and do the rounding?
Okay. So the fractional part is strictly less than a half. So rounding it to the nearest dollar means rounding it down. So it'll be $134.
$134, right?
Yeah.
So this is just application of the thing of the formula. But if you get the R wrong, then you're going to get this question wrong. Yeah, that's too bad. Because maybe on a school test, if you got the R wrong, but you used the wrong thing correctly, maybe you would get credit on a school test. But here, it's do or die, right? It's either right or wrong.
Yeah.
Nothing to be done, right? I mean, it's just standard stuff.
Yeah.
Yep.
Okay. Well,
okay.
Should we say anything about how dumb this question is?
Seth. That's a little passive aggressive.
Or shall we say it's unrealistic?
Oh! You mean for an analyst? Oh, you're talking about this part of the question,
or the whole question about what the analyst predicts. No, any analyst who makes a prediction like in this question, any such analyst. What would you say about an analyst who gives a client, this prediction?
Fine, let's not talk negative. Let's talk positive. If they wanted to ask the same question, maybe they should have said that a suit is on sale for $360 or a piece of whatever at the store, and every week they reduce the price by 28% to encourage people to buy it. Like a store's going out of business.
Oh,
right?
yeah.
And they have some stuff, and everything they sell, $360 chair, they reduce it by 28% a week till it sells.
Oh, yeah, they do that. I think they did that. I forget if it was Jordan Marsh
Yeah.
or Filene's
Right.
in
Right.
Boston.
Yeah.
They decades ago, they had these department stores. I think it was, I forget which one, had a bargain basement, and the way they priced their bargains was they reduced the price by a fixed percentage each week.
Right. Right. But it was compounded, right? It was
Oh
like,
yeah,
yeah, yeah, yeah,
sure.
yeah, yeah.
Well, that's what it means to
Right.
reduce it by a percentage
Right.
each week. It
So
means
then
it's
maybe they
compounded.
should have answered. So then if they did that question, it would have been very
Yeah, that would
normal.
be
That would have been normal.
because
Let's
yeah.
stay
But
positive. Let's stay
you
positive.
know, if, we just want to say that uh, prices on the stock market never behave according to the model that this quote analyst gave.
Okay, fine. So so let
Uh,
it go. Let it go. Let it go. Let it go. Let it
uh,
go. Okay, today's Throwback Thursday, which means we go back to a test that predates 2016. We don't go back that far. Seth and I took these tests in the 60s and 70s. We don't go back that far. We go back into the 90s. We located a question. I did not look at it too carefully, but something tells me that this is going to be something for a math PhD. So, here we go. But you also have to know something about geometry. So here's how Throwback Thursday. Oh, what is Throwback Thursday? Throwback Thursday, it's called Throwback Thursday. We go back to a test that predates the 2016 test. In 2016, they decided to make the test more in line with what you learn in school, as opposed to more of an intelligence IQ type thing. So just something, you'd never get a question you rarely would get a question like this in school, but you'd have to think carefully before 2016. Anyway, enough said. Wow, here we go. 3 lines drawn in a plane so that there are exactly 3 different intersection points. Into how many non-overlapping regions do these divide the plane?
yeah.
Oh, I don't know about you, but this is not great at these things.
All right. So shall I? Here we go.
So we're gonna have to
Draw
call
a
Seth.
picture.
We're gonna have to feed the Seth this problem.
Draw a picture.
Okay,
Right.
got it.
And then number the regions. 1, 2, 3, 4, 5, 6, 7.
You mean it's that easy?
I think so. Yeah.
You're kidding.
No.
Wow. What happens if the lines are parallel?
Then they will not meet at exactly 3 points, at exactly 3 different points.
Oh yeah.
And the number of regions will be fewer.
Oh yeah.
Yeah.
Let me try that. 3.
Only 6.
There are exactly 3 different. Oh. Wow, was that easy?
Yeah.
Oh. Okay.
And what if the 3 lines meet at 1 point?
Then they meet at 1 point. Oh, then you get 1, 2, 3, 4, 5, 6.
Yeah.
You get 6. Wow. So
Yeah.
what's the approach here? The approach here is to calm down and just
Yeah.
read the question and do what they say.
Yeah.
I'm really embarrassed. Right? I got a little turned off by the way it was worded. But I guess it was that. It's not really embarrassing. Right. 3 different lines are drawn in a plane. Oh, I got confused. I thought it was space. See, when I looked at, I didn't read the question that carefully. That was my mistake, but I thought maybe it was 3 lines drawn in space. 3-dimensional space.
Well, plane
Yeah.
means
Plane.
the 2-dimensional.
Yeah. Wow. Very humbling. Maybe next time I shouldn't jump to conclusions when I see a problem like this. Seth remained calm.
Well,
Seth read the question without overreacting to it. Good job, Seth.
Yeah,
Way to go. Okay,
no.
and much else? Okay, so you have to know what a plane is. A plane is a piece of paper. Two-dimensional space. Wow. Okay. I guess that's it, right?
Yeah.
Do you think they would ask this question? Doesn't it seem like this has a whole different feel to it, doesn't it?
Oh, yeah.
From a 2016 test.
Oh, yeah.
Post 2016 test. But it's a really easy question,
it's a test. Not to. Well, it's for at this level. It's a question about imagination and visualization.
Yeah.
And realizing that that every configuration of three lines in the plane with exactly three different intersection points generally looks like that. There's a one bounded region, a triangle, and then 6 regions,
right,
separated that are unbounded.
Yeah.
Yeah.
Okay. Wow. Okay, so I guess that's it. This actually completes.
What would be it even worse? Here is a much more sophisticated question.
Okay.
Replace. Oh gosh, I don't want to embarrass myself because I just can't figure out the answer right that quickly. But a more sophisticated question would be to replace 3 by n and give a formula that the n lines have the maximum number of different intersection points possible. How many regions?
The other way they can make this hard, whether it would be so much difficult question, is how many overlapping regions. Into how many overlapping regions?
Right? Oh, wow, that's a different story.
That's a whole different story, right?
Oh yeah. Okay, so maybe you could do that.
I
what do you mean by over unions of 1 and 2? Well, let's see. Would 4 and 7? I don't know. Would you count the region consisting of the points in 4 together with the points in 7?
I don't know.
Or would you count the points in 4 together with the points in 1?
I don't know.
Okay,
anyway, so it's way beyond anything. This way beyond the question. Okay,
yeah, but we can say that if you want to get the maximum number of regions, you take a figure with the maximum number of regions with fewer lines and draw a line that crosses every one of the old lines and doesn't cross them at any of the intersection points. It crosses. So suppose you have n minus 1 lines. How many regions are added if you draw an extra line that crosses every one of the n minus 1 old lines? Well, how many lines does it cross? N minus 1. How many regions in the new line are created? Well, there are n dots of crossing points on the new line. Sorry, there are n minus 1 dots on the crossing point where the crossing points of the new line, and so there are n regions added. Right? So every time you add a line, you add n regions. And therefore, the number of regions well, except that when you start with n equals 1, you get 2 regions. Okay, yeah. What you do is you each time you add a line.
Oh, so what is okay? Let's put this in English. Let's because many people, including myself, is not quite following. But I don't think we should just spend that much time in it. But Seth's basically saying that. Oh, that is weird. What is that about? Seth,
you start with one line. you get 2 regions.
Right, 1 line, 2 regions, yeah.
You add a second line, we get a region for here. What you get is what the second that when n equals 2, you get 2 pieces of the line, and a new region is added for each one. So we start, so when n is 1,
you get 2.
The number of regions is 2. When n is 2, the number of regions is 4.
You get 3.
When n is 3, you add how many? When n is 3, here are 2 regions. 1 region, 2 is the extra region. 1 region, 2 regions, 3 regions. We add 3 regions, and so we get 7. When n is 4,
yeah,
we have 7. We have the old 7.
Get 11.
We add 8, get 15.
Oh, really?
When n is 5, you add how many? You add 5 and you get how many? 22, etc.
Oh, so you're seeing a pattern. Wait.
Yeah, it's a pattern.
Wait.
Yeah.
So, wait, his iPod froze. Can't believe that Seth's doing this. Right. So then let's just do 5. 5. Come on. 3, 2, 1. So 5 is how many? 22. See, everyone, you see the pattern? Apparently, you take this 7, no, this 4 and add it to 3 to get 7. You take this 7, add to 4 to get 15. You take this 15.
Yeah.
Wait, no, but you take 15 and 5. You get 20. You get 20, not 22. What did we do?
Oh, really?
Wrong?
Yeah, I meant that. Yeah, I'm sorry.
Wait, no, but 7 and 4 is 11. Not 15.
Why am I doing twice? Yeah, okay. I just added wrong. Yeah. So
what is it? You have 4 regions, 7, 15 or 11?
And you have the old 7. The 4th line creates 4 new regions. So 7 and 4. I'm sorry.
Or 11.
That's 7. We get 11.
And 11 and 5 is 16.
And then, because 11 is 7 plus 4.
Right.
And then for 5 points, you get 11 plus 5 is 16.
So this is what mathematicians do, like Seth. You have one problem, and then you say, let's make it harder. No, let's look at the general case. And once you bring in the general case, then you really got to
Yeah.
You really got to think. And then sometimes you do the general case. What do they call this? Induction or something? Where you just
induction. Yeah.
Induction. You just sort of do enough of them to see the pattern. But the other way to do it was the way Seth did it wasn't induction, but actually thinking it through and figuring out like what's really going on. And generally you do both, right? You do induction maybe to tell you what to do, but then you think a little bit about, wow, how does that really work? And then you got a really good understanding of it. And then you go on to an even more complicated problem. Like maybe a three-dimensional possibility of all these things, right? That's what you do.
Yeah.
That's what Seth does. That's what mathematicians do. Okay, good. So that's a little lesson in what people do when you do math.
Mm-hmm.
So this completes a complete SAT test on our post-2016, and we are very tempted. We're probably going to go to Khan Academy to find practice questions, but that starts tomorrow. Okay, everyone. So have a great day, and we'll see you. We'll be back. Expect to be back tomorrow doing more SAT math question of the day. And please like us, dislike us. Please give us comments on how we can improve what we're doing to help you approach. Again, emphasis on the word approach, SAT math questions. Okay, everyone. Have a great day.
Bye.